The James Webb Space Telescope, moreover known as Webb or JWST, is a reliable pioneer that has uncovered astounding pieces of information concerning stars, planets, galaxies, and other entrancing boundless eccentricities, as well as setting new guidelines for scientific inquiry. Webb is hailed as the regarded replacement for the Hubble Space Telescope. People from around the world are sharing photographs or utilizing raw data to make new revelations. Just 3 minutes ago, James Webb captured the most remarkably startling picture ever found in history. 1 year has passed since the amazing James Webb Space Telescope revealed its first vital image of the universe, stunning astronomers across the world with its superb detail. Yet, its latest finding is a shocking image of the universe that we have never seen before. What has been seen up to this point by the James Webb Space Telescope is revealing more advances than it managed previously. Researchers say the replacement for the Hubble scope uncovered new data about star development, galaxy formation, and the early universe. Only 1 month after the initial photographs were released, the photos were astonishing, revealing the universe thoroughly. Since then, the number of exposures has soared, providing researchers with a gigantic data motherlode. James Webb Space Telescope's pictures of grandiose tarantulas, record-breaking space smoke, stars, and other wonderful brilliant objects have been documented. This satellite observatory's top-tier advancements allow us to peer farther into space than ever before, revealing previously obscured details about the universe. As a method of reviewing the first year of the James Webb Space Telescope's operation, NASA released a picture showing a small star-forming region in the Rucci Cloud complex. The picture shows jets shooting from baby stars as enormous development waves of different assortments influence atomic hydrogen, which makes up the red development. The presence of a circumstellar disk prompts several theories around a few stars, suggesting the chance of planet formation in the far-off past. The picture could show significant turmoil, yet according to NASA, this sublime nursery is small and quiet compared to others. The vigorous stars in this region are about the size of our Sun or even smaller, making it the closest star-forming area to Earth. This image was captured by the primary camera of the observatory, the Webb Space Telescope's close-in camera, which captures stunning pictures in 2 distinct infrared ranges. Additionally, the Space Telescope has improved our understanding of exoplanets, or planets that orbit stars other than our Sun. James Webb is particularly skilled at concentrating on distant massive galaxies. The satellite observatory discovered its first exoplanet, LHS 475b, at the beginning of 2023. The planet is 41 light-years away and has a size similar to Earth's. According to NASA, James Webb is the only operational telescope capable of sequencing the atmosphere of Earth-sized exoplanets. The discoveries illustrated how precise the telescope was. Exoplanets are now another frontier for cosmologists to explore. The James Webb Telescope also found evidence of ancient galaxies that, from a theoretical perspective, should not have existed. The Swindon School's Advancement Lab and its remarkable team have discovered 6 legendary ancient galaxies, called universe breakers, which could significantly affect our understanding of space. These epic galaxies could have appeared between 500 to 700 million years after the Big Bang, according to the results. Recently, the telescope's infrared sensors identified them, allowing us to look back in time about 13.5 billion years when stars and galaxies were much more settled. The massive size of the universe breakers has left researchers puzzled. Galaxies in the early universe were expected to be 10 to 100 times smaller than their current size. These 6 objects might be billions of times heavier than our Sun, and the total mass of stars in a single galaxy could be 100 billion times heavier than our Sun. Attempting to fathom something so massive feels uncomfortable despite technological advancements. Planets that are exceptionally large to exist have specialists confused. None more so than the discovery of a planet thought to be too massive for its star. This has led to a reassessment of our entire understanding of planet formation and planetary system design. A planet that is roughly as large as Earth has been observed in research from Pad 8 Tails, suggesting that this planet is in a planetary system around the ultra-cool star LHS 3154, a star that is generally smaller than our Sun. Before actually seeing it for themselves, researchers did not think such a situation was conceivable, yet new evidence shows that the largest planet in our solar system is indeed orbiting one of the universe's smallest, coolest stars. ultra-cool dwarfs still have practically no understanding of the universe. This discovery shows that a planet of this mass orbiting a star with such a low mass defies our presumptions. These stars could have formed an immense gas and dust cloud, and planets could have arisen from the gas and dust that remained in the material disk around the infant star. However, it is not conjectured that the planet-forming disks around the low-mass star LHS 3154 contain sufficient solid mass to create this planet. Nonetheless, it exists, so we must now reevaluate our speculations about stellar and planetary development. A good relationship is balanced. A star with an outer heat source should maintain its internal temperature. You need to draw closer to the heat source as its temperature decreases. Planets are the very planets that should be warm enough to support liquid water and should be closer to their stars. For instance, Earth is in the habitable zone due to the warmth and light it receives from the sun. The distances of different planets from our sun are either too perfect or too small for them to receive the right amount of light to support life. Now, imagine a universe with a much cooler star. Getting closer to the fire would be similar for planets orbiting a cold star to get the right amount of energy to support life. The planet size should also be adjusted to provide the best distance for energy and light to support life. Returning to our previous discussion, there are various theories about why the planet might have formed close to the small star. According to a widely held belief, the planet could have been much larger initially. Over the long term, the planet would have lost much of its mass. However, this hypothesis has a significant flaw since large mass causes a planet to lose more gases than solids. In this case, it is conjectured that most of the planet's mass would have been gases, which conflicts with the finding. Another explanation is that this massive planet formed far from the small star. If the planet had been able to avoid getting too much light, it would likely be ice-covered. The star could eventually gravitate toward this distant planet, resulting in this massive planet being close to the small star. Although there is a chance that both ideas could explain the observed planet-star pair, researchers are still unable to fully understand the anomaly. With cutting-edge technology like JWST, researchers are now examining planetary systems more meticulously, and each new finding is pushing them forward. We have delved deeper into how the universe has formed over the last few decades than we have in the most recent 30 years. The enormous amount of data provided by the telescope has already led to major scientific advances that have astonished space experts and ignited interest in future space exploration. With the James Webb Space Telescope in operation for a year now, one thing is clear. The universe is undeniably more complex than we previously envisioned, and there are many questions we still need to answer. The James Webb Space Telescope, JWST, launched by NASA in December 2021, represents a significant leap forward in our quest to understand the universe. Known as the successor to the Hubble Space Telescope, JWST is equipped with cutting-edge technologies designed to capture unprecedented views of the universe across a broader range than ever before. At the core of JWST's capabilities is its large primary mirror, boasting a diameter of 6.5 meters, 21.3 feet. This size is over twice that of Hubble's mirror, allowing JWST to collect and focus significantly more light. This increased light-gathering power enables JWST to observe fainter and more distant objects with remarkable clarity and detail. One of JWST's key instruments is the near-infrared camera NIRCam, essential for observing the universe in the infrared range. Infrared light is crucial for studying celestial objects because it penetrates cosmic dust clouds that block visible light, revealing hidden stars, galaxies, and planetary systems. NIRCam operates in 2 infrared wavelengths simultaneously, providing astronomers with valuable information on the temperatures, compositions, and movements of distant celestial bodies. Another critical instrument on board JWST is the Near-Infrared Spectrograph, NIRSpec, which disperses light from distant objects into its component colors or spectra. By analyzing these spectra, astronomers can determine the chemical composition, temperature, and motion of stars, worlds, and exoplanets across immense distances. This capability is invaluable for studying star formation, planetary system development, and the atmospheres of exoplanets. JWST's mid-infrared instrument, MIRI, complements NIRCam and NIRSpec by focusing on even longer infrared wavelengths, which are crucial for studying the coolest objects known to humanity. MIRI's advanced detectors and spectrographs enable detailed observations of cold gas clouds, dust-shrouded star-forming regions, and the thermal emissions from distant planets. Along with NIRCam and NIRSpec, MIRI provides a comprehensive view of the universe across a broad spectrum of infrared wavelengths. One of the most anticipated capabilities of JWST is its ability to study exoplanets, planets orbiting stars beyond our solar system. JWST's powerful instruments allow astronomers to examine the atmospheres of exoplanets as they pass in front of their host stars, a technique known as transit spectroscopy. By measuring the changes in starlight passing through an exoplanet's atmosphere, JWST can detect gases such as water vapor, carbon dioxide, and methane, providing insights into the planet's atmospheric composition and potential habitability. In addition to its scientific instruments, JWST's orbit around the second L2 Lagrange point, roughly 1.5 million kilometers, 930,000 miles, from Earth, ensures minimal interference from Earth's atmosphere and heat. This stable vantage point allows JWST to maintain a consistently cold temperature, essential for its infrared observations, and provides continuous views of the universe for extended periods. The journey to launch JWST has been a decade in the making, involving global cooperation among NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. Each agency contributed significant expertise and innovation to the telescope's development, ensuring its success as a global endeavor in space exploration. Scientifically, JWST aims to resolve fundamental questions about the universe's origins, development, and creation. By observing the universe in infrared light, JWST can peer through vast dust clouds, study star and galaxy formation, and explore the conditions necessary for planet formation and life. These observations will build upon the discoveries of past telescopes like Hubble and transform our understanding of the universe. One of JWST's primary scientific objectives is to study the first stars and galaxies that formed in the early universe. By detecting the faint infrared light emitted by these ancient objects, JWST can probe further back in time than ever before, unraveling the mysteries of how the universe evolved from a hot, dense state to one filled with stars, galaxies, and eventually planets. Another key area of investigation for JWST is the study of star formation and planetary systems within our own Milky Way galaxy. JWST's high-resolution imaging capabilities allow astronomers to observe protostars, the precursors to stars, embedded within dense gas clouds. These observations provide insights into the processes that drive star formation and the evolution of planetary systems around young stars. Additionally, JWST's observations of planetary systems beyond our solar system offer a glimpse into the diversity of exoplanets and their potential for habitability. By studying the atmospheres of exoplanets, JWST can identify chemical signatures that might indicate the presence of life-supporting conditions, such as liquid water or organic molecules. These discoveries will inform future research and missions aimed at finding Earth-like planets capable of supporting life. Beyond its scientific goals, JWST represents a technological marvel in space engineering and instrumentation. The telescope's intricate deployment sequence, including the unfolding of its segmented mirror and sunshield, required precise engineering and testing to ensure successful operation in space. JWST's instruments underwent rigorous testing to withstand the harsh conditions of space, including extreme temperatures, vacuum conditions, and radiation exposure. The development of JWST also pushed the boundaries of international collaboration in space exploration. Researchers and engineers from around the world contributed to the telescope's design, development, and testing, leveraging expertise in optics, material science, advanced engineering, and astronomy. This collaborative effort ensured that JWST would achieve its scientific objectives and pave the way for future space missions. Looking forward, JWST promises to revolutionize our understanding of the universe and inspire future generations of astronomers, scientists, and space explorers. The telescope's extraordinary capabilities will enable discoveries that were once thought impossible, from unraveling the mysteries of dark matter and dark energy to studying the atmospheres of distant exoplanets. Moreover, JWST's findings will have profound implications for our understanding of Earth's place in the cosmos and our potential for life beyond our solar system. Summary: the James Webb Space Telescope stands at the forefront of 21st century cosmology, poised to reshape our understanding of the universe. With its advanced instruments, global collaboration, and ambitious scientific goals, JWST represents a testament to human ingenuity and curiosity about the cosmos. As JWST embarks on its journey of exploration, it holds the promise of uncovering new revelations, addressing key questions about our origins and existence, and inspiring future generations to explore the wonders of the universe firsthand.